Okay. All right, so this last lesson is going to talk about modeling with quadratic functions. Okay, one thing you need to know is this. Okay, when you drop a ball from top to bottom, okay, the longer the ball takes to hit the ground, the faster the ball is going to go. And this is a perfect example. Okay, here's a box, and let's say there's no air resistance on the box. Okay, the further it goes, the more ground it's covering between every second, because notice how between 0 and 1 second, it's covering this much. 1 to 2, it's covering more. 2 to 3, it's covering more. 3 to 4, it's covering more. Okay, so this explains a solid quadratic function. Okay, it explains a perfect quadratic function. It's not linear because remember, linear has to be consistent, and neither will absolute value or step functions work essentially. So that's what's going to be used for that idea. Okay. First example is very simple. Using quadratic functions to model area. A company offers a rectangular pool size with dimensions as shown. Each pool includes a deck around it. If Carolina wants a 15-foot wide pool with a deck, we need to figure out the width of the pool so that it can fit inside. Okay, so let's write a quadratic function. Well, here's the thing. Okay, we know around it is 4 feet. So all the way across is all 4 feet. Okay, so there's 4 and 4. So I can say that this entire dimension is 2x plus 8. And then from here to here, it's x also plus 8. So notice how, boop, when we find the area of the whole pool deck with the pool inside, we have that set up. There's our area. Okay, now we need to find the area of the pool when, and the deck when x is 15. Okay, so notice how, boop, x is 15 because it's given to us. There you go. Okay, so we plug in 3 for x and we're good. Okay, so now instead of 2x, boop, it's 3x. Okay, so I'm going to change 2 to 3. So now in this case, it's going to be 3x plus 8. Okay, and then x plus 8. Just changes the equation, really. We use the box method. We're going to do this off the top of our heads, though. 3x squared, okay, 24x plus 8x, that's going to be 32x, and then plus 64. There you go. Then we plug in 15, and we find the area after that, okay? Obviously, the bigger the length of x, or the bigger the length with x, the bigger the pool is going to be, okay? Keep that in mind for sure. Next example. This is also important. Vertical motion model. This is a very common equation to find the vertical motion of an object as it's falling on the ground, okay? H of 0 is what you start off with, the initial height. B of 0 is the speed of which an object is falling or going up, depending on the direction it's going. If it's negative, it's going down. If it's positive, it's going up. A diver jumps off a high platform at the initial velocity of 16 feet a second. So this is going to be my B of 0. Let me be eraser. Boop, boop, B of 0. That's your starting speed. What quadratic function represents the height? Well, just plug in 16 for t, or next to the t, boop, you got it. Okay, notice how the height of the platform is 30. This is your h sub 0. Boop, plug it in, we got it. How many feet above the platform will the diver be at the highest point? And notice here, we find the vertex. Use your negative b over 2a. You know, you plug in your b and your a. It's 1/2, that's the x value of the vertex, boop, boop, boop. Plug it in to find the y value of the vertex, boop. He's gonna be 34 feet from the pool, okay? Find the diver's maximum height above the water if he dives from a 20-foot platform with an initial height of 8 feet a second. This is your B of 0. This is your, whoa, I mixed it up. 20 feet high is your H of 0. So 20 is your H of 0, 8 is your B of 0. Now let's find it, okay? When we make the equation, it's negative 16 t squared plus 8t, and then plus 20. Now let's find the vertex, okay? Here we go. Let's do this in a different color. X equals negative parentheses 8 over 2 times negative 16. Okay, it's going to be 8 over 32, which essentially, believe it or not, it's going to be 0.25. Okay, we plug that in to find the y value of vertex. So negative 16.25 squared plus 8 times 0.25, and then plus 20. Not a fan of this. Let's use Desmos instead. Boop. Okay. Negative 16.25 squared plus 8. What the heck? Okay, there we go. Plus 8.25 and then plus 20. There you go. Now height is 21. Okay, the height is 21. There you go. That covers half of it. Go to the other half. Okay. Now we're going to make a, you know what? I'm going to ignore residuals. I'm not a fan of the residuals because residuals only just talk about how far apart the actual price is. So believe it or not, we're actually going to skip this. Well, we can make a scatter plot and then make it. Because actually what I want to focus more on is this. Okay. Making an equation using the quadratic regression feature, okay? And I'm gonna give you the program. All you're basically gonna do is you're gonna plug in these points and then you can actually make a quadratic regression model, okay? Based on whatever they give you, okay? A, B, and C, and then R squared. If R squared is close to 1, then that means it's more accurate. If it's closer to -1, it's actually not as accurate, okay? Once you make your equation, just plug it in, then you're good, okay? So let's actually do this as an example to see if it works. And I have the website that we're going to be using, okay? And it's going to come from this, okay? Not that many points, so let's plug them in. And I'll give you guys the website, okay? 0, 745. Okay, the next one, 1, 846, 2, 9, 10. So 1, whoops. Okay, 1, 846, 2, 9, 10, 3, 952. And then 4, 1008. Okay, let's execute it to figure out what A, B, and C are. Okay, and notice how it's pretty accurate. Okay, if we look at the this here, yeah, it's actually flipped. Okay, yeah, it's actually flipped as a matter of fact. So in this case, the idea actually, the way that it's written is actually more or less flipped. Because obviously for the 749, it's going to be really, really condensed. So A, B, and C actually should be flipped essentially, okay? Did they give you R? I believe they do. It's a strong correlation essentially, but there's your equation here. So we're gonna use the idea that's flipped. This is your A, that's your B, and that's your C because it is opening downward. Okay, it is opening downward. Okay, that actually covers everything, believe it or not. Okay, so that covers everything. I may or may not ask you that question or one of those questions, but for sure, a question using this idea. That's going to be important. Because remember, area is two functions or two dimensions multiplied together, and that will come up for sure, as well as this. These are more important than anything else. Okay, that'll do it. Have fun. Get to work.